All right, so this problem says a small block of mass 200 grams starts at rest at A, slides to B, where its speed is 8 meters per second. Then slides along the horizontal surface a distance of 10 meters before coming to rest at C. Okay. What is the work of friction along the curved surface? What is the coefficient of friction along the horizontal surface? Okay. So here, along the curved surface, we will not be able to calculate the coefficient of friction. All we can do is calculate the work done by friction force. Here we can calculate the coefficient of friction because we know the normal force. Here the normal force is changing on the curve. Okay, so that's why we won't be able to calculate that. Yeah. So anyway, so while this thing is falling down, there's the force. These are the forces acting on it: friction force, the force of gravity, and the normal force. Okay. So the net work done in going from A to B, the net work done is the work done by gravity, work done by friction, and work done by normal force. Okay. Now the normal force always does zero work because, all right, it's always perpendicular to the displacement. Okay, so this does zero work. Okay. So, and work done by gravity. Okay, so we haven't proved this, but when an object falls at distance h, the work done by gravity is mgh. Okay, and it doesn't matter what the path is. If it's a curved path, what you can do is, so here's sort of a quick and dirty proof. If it's a, well, let me, okay, then you just break it down into paths like that. Okay, during the horizontal leg of the path, no work is done. Okay, and anyway, that's the work done by gravity. So that's a quick and dirty indication of that. Okay, and the work energy theorem says this is equal to final kinetic energy minus initial kinetic energy. Okay, so work done by gravity is mgh plus work done by friction is equal to final kinetic energy minus initial kinetic energy. Initial kinetic energy was 0. Okay, the object started off at rest. So work done by friction force is okay. Work done by friction force, should it come out positive, negative? Negative. Okay, it'll always be negative. So hopefully this number is bigger than this number. Okay, all right. So 1/2 mv squared minus mg. All right, what is the mass of the object? 0.2 kgs. And the final velocity is 8 meters per second. And the object fell 4 meters. And so as promised, friction did minus 1.44 joules of work. Okay. All right. Now they ask you, what is the coefficient of kinetic friction along the horizontal surface? Okay, so now you're on the horizontal path, and the friction force is in this direction. Now you know what the normal force is. The normal force is equal to the weight, and you traveled 10 meters. Okay, so now net work done is work done by gravity plus work done by the normal force plus work done by friction force. Now along this path, gravity and the normal force do zero work. Okay, so, and that is equal to final kinetic energy minus initial kinetic energy. Okay, so in most of these problems, we are using the work energy theorem, which says the net work done is equal to change in kinetic energy. Okay, I don't want you getting lost on it. So the net work done is the work done by all the forces acting on the object. So when it moves from here to there, all the forces acting on it are the friction force, the force of gravity, and the normal force. Okay, these two guys did zero work, only this guy did work. Okay, that's where we got all of this from. And what is the final kinetic energy? Why is it zero? It stopped. Okay. All right, so let's see. Minus Fs is equal to minus K. And what was the friction force? Mu K times mg. Okay. So we have mu K times mg s equal to 1/2 mv initial square. V initial square was initial velocity is, what is the initial velocity? 8 meters per second. S is 10 meters, and so on. The mass cancels. What does that tell you? That's right. And this is a good thing because let's say you were UPS or something like that. You have all these packages. You just slide them down an incline and they'll get to the truck. Every package will stop at the same location, assuming the coefficient of friction is the same. If you make them from the same cardboard box, that'll be the same. Okay, so that's the kind of stuff. All right. What are the units for mu K? No units. It's a dimensionless number.